Well, hello. We are back live with another study session on Freecodecamp. We are at the moment in the basic data structures module. I'm going to be waiting for about 2 minutes to give a chance for any people to join. And if not, I'll just be starting and some people may join in the meantime. Now, if you remember, if you're here last time, we were basically going through the push and unshift methods on array. So the next lesson is gonna be this one, where we're gonna use pop and shift. And once we get started, we're gonna see what those do. And it seems to be a slow day today. I didn't see any people really waiting. I think it was just showing one person waiting, and probably that was me, which is funny. I was waiting on myself. But I don't know. Sometimes I think this software is not really showing when people are watching, because last time I've been getting some likes during the live, even though it was only showing one person watching. So unless that person went and liked the, well, I see one person is watching at the moment. So I guess I'm going to get started. Hello to whoever has joined. If you want, you can say hello in the chat. If not, we'll just gonna get started, and I'm gonna keep watch if there's any questions. I'm gonna keep a watch for the comments. All right, so we're at these lessons. A lesson where it says remove items from an array with the pop and shift. And it says both push and unshift, which have learned last time, have those ones we were basically using to add elements at the end of an array or at the beginning of an array. And they say they both have corresponding methods that are nearly functional opposites. Pop basically removes one element from the end of the array, and unshift removes one element from the beginning of the array. So they say, as you may have guessed by now, instead of adding, pop removes an element from the end of an array, while shift removes an element from the beginning. The key difference between pop and shift and their cousins, push and unshift, is that neither method takes parameters, and each only allowed an array to be modified by a single element at a time. So while with push we can push, with push and unshift we can push more elements at a time. With pop and shift we can remove elements, but only one at a time from the beginning or from the end of the array. Sorry, I just have something in my eye. And they give an example here of what's going on. I'm going to explain it my own way. Um, so basically, let's say we have an array, const numbers, for example, which has some elements in it, right? Like this. And we want to remove the last element. We can say numbers pop. And if you say numbers pop, then that will remove the last element, which is 4. So if I console log the numbers after I remove the last element, clear, and I'll say here I will run the program node code gs, and you can see we only have 1, 2, 3. And if we would have another pop after this one, then we would have 1, 2, because we remove this one and then we remove this one, right? Like this. And it's good to know that this method, and also let's take this one out, and let's say numbers shift. And if you use that one, this one will remove an element from the beginning of the array, right? So it will remove the 1. Okay, now it's good to know that both of these methods, while they're removing something from an array, they also return the element that they remove. So going back to pop, which removes an element from the end, if I say const last last element equals numbers pop, what's happening here? Number pops will remove the last element and it will put it in this variable. So now if I console log numbers and I also console log last element, you will see that the last element has been retained in that variable. As you can see, we have 1, 2, 3, and 4 was stored in last element. Okay, so when you remove them, if you want, you can store them in something else and use them. Okay, all right. So here it says we have defined a function pop shift, which takes an array as an argument and returns a new array. Modify the function using pop and shift to remove the first and last elements of the argument array and assign the removed elements to their corresponding variables so that the return array contain their values. So popped equals array. Well, sorry, my keyboard is a little bit shit, so the keys keep falling, especially the ones from command and save, because I save so much. Anyway, so we store the last element in popped, so array pop, and shifted equals to r shift. All right, and we return them. Okay, so let's run the tests, and that works. Okay, all right. So here it says remove items using Splice. Okay, so we have learned how to remove elements from the beginning and end of array using shift and pop. But what if we want to remove an element from somewhere in the middle, or remove more than one element at once? Well, that's where Splice comes in. Splice allows us to do just that. Remove any number of consecutive elements from anywhere in an array. Splice can take up to 3 parameters, but for now we'll just focus on the first two. The first two parameters of Splice are integers, which represent indexes or positions of the array that Splice is being called upon. And remember, arrays are zero indexed. So to indicate the first element of the array, we would use 0. Splice first parameter represents the index on the array from which we begin removing elements, while the second parameter indicates the number of elements to delete. For example, here, if you say array splice 2, which 2 it says from index 2 remove 2 elements, right? So if we say from index 2 remove 2 elements, this is the index 2 because we have 0, 1, 2. So from here remove 2 elements, so it will remove this 2 and you will get today was great, right? Splice not only modifies the array is being called on, but it also returns a new array containing the value of the removed elements. So if you have an array like this and you say new array equals array splice 32, you're basically cutting a part of the array and storing it in this new array, right? So you can use Splice basically to remove from an array or just get one part for and use it, right? So basically when you say new array equals to array splice 32, basically it will slice from 2 elements, so these ones, and we'll put this array with these 2 elements in new array. So array at this point will remain with I am filling, and new array will have the values really and happy, right? Because you have stored in here. So here they say we've initialized an array R. Use Splice to remove elements from R so that it only contains elements that sum to the value of 10. Okay, so basically they want us to slice a part of it or different parts of it so that the elements that remain sum to the value of 10. So let me copy this in Visual Studio to explain this, right? So if I copy this and let's look for some values that sum up to 10. So we get, for example, 4, 5, and 1, which sum up to the value of 10. So that sum up to the value of 10. We have 5, 2, 1, 2, 4, 5. Yeah, so basically we kind of have to remove this element and these elements, right? I think we have to use it twice. So basically we have to say array splice, and we want to remove from index 0 one element because we want to remove this, just this one, right? So we remove that one, and then we remove this at this moment will become this, right? And we want then to basically splice these elements out as well. So we want to say array splice 3, and I think the thing is here you can say how many elements from 3 it should remove, but if you don't put another number, then it will just do it until the end. So you could say from 3 4 elements like this, and now if we console log R, but let's put the element that we took before because this is what it should start from, right? So if we console log R, we get 4, 5, and 1, because what's happening, the first one removes this element, and then we remove from 3 4 elements, right? From the index 3 4 elements, so we will just have 4, 5, and 1, which sum up to 10, right? But like I said, you don't have to, if you're basically going until the end, you don't have to give the second parameter. It will just go until the end if you just give the first index, right? So if I do this again but without that parameter, we still get 4, 5, and 1, right? So let's just copy this and run it, and that works. Okay, all right. And here it says add items using Splice. Remember in the last challenge we mentioned that Splice can take up to 3 parameters. Well, you can use the third parameter comprised of one or more elements to add to the array. This can be incredibly useful for quickly switching out an element or a set of elements for another. So for example, you have this array and you have start index 3 and amounts to delete 1, and basically is what we're going to do is we're going to go from the third index, delete this element, and instead of this element it is saying from this element delete 1, right? So it's deleting this one at index 3, and then the next parameters that you add are basically the numbers that it should add in the place from where it's removing stuff, right? So basically what it's doing here, it's removing this 12 and it's putting 13 and 14 to basically make this sequence correct, right? So it's saying the second entry of 12 is removed and we add 13 and 14 at the same index. The numbers array will be 10, 11, 12, 13, 14, 15. So let's explain this with our own different array. Let's say we have 1, 2, 7, 8, 9, and let's say here we have another 2 of 2, right? And instead of having this sequence like this with some twos and the other missing there are some number missing from 1 to 789, and we have some duplicate 2. We want to remove these two twos and put the other numbers that we are missing. So what we can say is we say array splice, and we want to remove from index 2 because we have index 0, index 1, index 2. We want to remove 2. So from index 2, remove 2, and we want to add instead in that place, we want to add 3, 4, 5, 6, 7, not 7, because 7 we have already, right? So now if we console log R, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right. All right. So here they say we have defined a function HTML color names which takes an array of HTML colors as an argument. Modify the function using Splice to remove the first two elements of the array and add dark salmon and blanked almond in their respective places. So what we want to say is R equals, well, not R equals, because when you're splicing, you're basically modifying the array directly. You're not returning another array. So we're just gonna say array splice, and we are going to say remove from index 0 two elements because we want to remove the first two elements, and instead of them we want to add dark salmon and blanched almond. All right. Okay. Okay, so here it says copy array items using slice. Now slice, it's a bit similar to splice, only splice modifies the original array, while slice just like slices part of it and it returns it to you, right? So the next method we will cover is slice. Rather than modifying an array, slice copies or extract a given number of elements to a new array, leaving the array it is called upon untouched. Slice takes only two parameters. The first is the index at which to begin extraction, and the second is the index at which to stop extraction. And by the way, we are going to go through this, but if you want, you can go on my channel. I have an in-depth explanation of this method, both slice and splice, and the differences between them. So it says slice takes only two parameters. The first is the index at which to begin extraction, and the second is the index at which to stop extraction. Extraction will occur up to but not including the element at this index. So when you're slicing and you give some indexes, it will basically slice from the first index and include it, and up to the last index, but not include the element at the last index in the sliced thing that we get back, right? So here it says consider this, you have an array and we have weather condition slice from 1 to 3. So it will basically slice from 1, 2, and this is 3. So you're basically gonna slice up to 3 but not 3. So we're basically slicing just these two elements. So we will get snow and sleet, while weather conditions should still have, because when you're slicing and you're putting in this variable the slice, you're not actually taking anything from this one. You're just copying something in this one, but you leave the original array the same. So it says in effect we create a new array by extracting elements from an existing array. So here they say we have defined a function forecast that takes an array as an argument. Modify the function using slice to extract information from the argument array and return a new array that contains the string elements warm and sunny. So basically when it's called with this one, it should extract the elements warm and sunny. So what you want to say is r equals r. Oh wait, we could actually do something else. We can say store it in another variable, and we can say const segment equals array slice, and we want to basically cut from the second index to index 2, 3, 4 to index 4. So we say array slice 2 and 4, because we say to index 4 because this one will not actually, the last index will not actually be included. Now a way for me to basically know exactly where it's gonna stop, instead of saying, oh, the last one is not included, when I'm saying the indexes, I'm basically saying the first index, and then I'm saying, okay, how many elements do I want to cut from here to where I want to cut, how many elements there are. So because I want to cut these 2 elements, I'm just basically adding 2 to this one, and I'm saying, okay, cut up to index 4. And that way I don't have to get confused about, oh, is this one included or not. I'm just saying, okay, cut 2 elements from this index. Okay. All right, so let's run the test. Forecast shows return. Okay, right. So here we're still returning array because I changed this thing. So what I want to return is segment. All right. Okay. All right. So here they say copy an array with the spread operator. While slice allow us to be selective about what elements of an array to copy among several of other useful tasks, ES6 new spread operator allow us to easily copy all of an array's element in order with a simple and highly readable syntax. The spread syntax simply looks like this, and you just have some 3 dots. In practice, we can use the spread operator to copy an array like so. So you have an array like this, and then you want to copy these elements in another array. Okay. So basically what you can say is say, okay, this array equals to array, and we're spreading the elements of this array in this one. And you may wonder, okay, why don't we just say, if you're newer to JavaScript, you may wonder why we don't just say let that array equals this array. Why do we have to make a new array and spread these elements instead of just saying let that array equals to this array? And while you can do that, if you want to copy values from primitive types, like if you have a variable const sum num equals, or let's just say let, because we want to, okay, let sum num equals 1, and then you say, okay, let another num equals 2, no, equals to sum num, right? So you can easily do this with primitives, and if I console log another num now, I will get 1, right? So I get 1. And but what happens if I give to another num now, I change its value to 3 maybe. If I console log, well, not here. If I console log another num, I will get 3 now. But what happens if I console log some num now? Is it still gonna be 1, or what's gonna happen? It's probably gonna still be 1, right? So sum num. If I console log sum num after I change another num to 3, sum num should still be 1. right? It's still 1. So if we can basically do this, just give the value that it is in some num to another num without any problems, why can't we, when we have an array like const some numbers equals to 1 2 1 2 3, why can't we just say const another numbers equals to some numbers? Why we don't really want to do that? Because basically array and objects, the way they work, arrays have basically an address in memory, and when you're saying another numbers equals to some numbers, you're not actually creating another array with the same elements that the first array has. What you do, you just give another numbers the same address in memory that's the some numbers array has, right? So at the moment, if I console log another numbers, let's just call it other numbers, right? If I console log other numbers, it will still show 1 2 3, right? Because it points to the same memory. So you say, okay, so it still points and it's okay, right? But no, it's not okay. So let's console log this and let's get to the root of the problem. We get 1 2 3, right? Now here, what is happening if I basically push other numbers? I push in this array after I say other numbers equals to some number. If I push the elements 10 and 9, right? So I push these elements at the end. If I console log other numbers now, it should show 1 2 3 10 9, right? Because I pushed some numbers, right? So let's do that again, and we get 1 2 3 10 9, right? Because we pushed some number. But now if I actually console log some numbers, which I never pushed into some numbers other elements, let's clear this. So I console log some numbers which I never really modified by saying some numbers push something, right? And if I do that, I still get 1 2 3 10 9. I modified this one, but this one also has the same elements that I pushed. And basically that's because when you're doing something like that, you're saying, okay, basically you I want you to basically have the same address in memory that this array has. You just have the same address, so you're basically the same, both your elements and your address, so you're basically all the same, right? Nothing is different. You don't only have the contents of this array, you also have its address, so you're basically the same. Okay, so if you just want to have another elements with another array with the same elements, that's when you use something like that. You say const other numbers equal to some numbers, and you basically in here you just spread the elements inside another array, because when you're using these brackets, you're creating another array, so another memory, and in that memory you just dump the same elements that are in the other one, and that way you create a copy, right? So now if I console log some numbers, it should still just be 1 2 3 because it points to another address. Now this one won't point to that address anymore, so when you push into it, it won't push anything in that address that was for this one, right? So let's do clear, and you have 1 2 3, and if we console log other numbers, we have 1 2 3 10 9, right? All right, I hope you understood that. Okay. So that array equals true to undefined. This array remains unchanged, and that array contains the same element as this array. So here it says we have defined a function copy machine which takes R, an array, and num, a number, as arguments. the function is supposed to return a new array made up of num copies of R. We have done most of the work for you, but it doesn't work quite right yet. Modify the function using Splice syntax so that it works correctly. Hint, another method we have already covered might come in handy here. So let's see what they say. We have this R and this number, and we have new array, and we're saying while num is higher than or equal to 1, num minus minus return new array, but we're not actually doing, we're basically not doing anything in here. What we want to do is we say new. So in this loop we're basically gonna go from num, which is the number of elements we want to add, to 1, and for each one we're gonna put a copy of R in new array. So we want to say new array push, and we want to push an array, and in this array we're gonna spread R. Alright, so we get this. With 2 we get this. If we put here 3, we're gonna get this, right? Okay. Alright, let's go further. Here it says combine arrays with the spread operator. Another huge advantage of the spread operator is the ability to combine arrays, or to insert all the elements of one array into another at any index. With more traditional syntaxes, we can concatenate array, but this one also allows us to combine arrays at the end of one and at the start of another. Spread syntax makes the following operation extremely simple. So here we have an array with these elements, and then we can say let that array equals to, okay, I first want these elements, then I want to spread all these elements from this one at this position after these two, and then we can add another one, right? So we're basically spreading some elements from an array in the middle of another array, right? Using Splice syntax, we have just achieved an operation that would have been more complex and more verbose had we used traditional methods. So here they say we have defined a function spread out that returns the variable sentence. Modify the function using the spread operator so that it returns the array learning to code is fun. Right? So we can say let sentence equals to, and we have basically we have to say learning to code is fun. So we say learning is going to be the first element, then we need to code, so we spread the elements of fragment. So we have learning to code, and then we just want to add is, and we want to add fun as well. Okay, all right, okay, all right, okay, all right, okay. Check for the presence of an element with index of. Since arrays can be changed or mutated at any time, there's no guarantee about where a particular piece of data will be on a given array, or if that element even still exists. Luckily, JavaScript provides us with another built-in method, index of, that allows us to quickly and easily check for the presence of an element in an array. Index of takes an element as a parameter, and then called it returns the position or index of that element, or -1 if that element does not exist on the array. So here they give the explanation. I'll give the explanation here. Basically, if we have an array const numbers equals to 1, 2, 3, 4, 5, 10, 18, there's no 5 here. Okay, and we want to find if an element, like for example 4, is in the array, then we can use numbers index of 4, and when we call this index of method on the array, we're basically gonna get the index of 4, so we should get 3, right? Because the element of 4 is 3. We have 0, 1, 2, 3. Okay, so let me console log this. All right, and we should get 3, like I said, right? We get 3, we get the index of 4. If we put 18, we should get 5, right? Okay, now if that element that we're looking for is not the array, what we're gonna get from this one is going to be -1. So if we say numbers index of something and we get -1, we know that element is not in the array. So 100, and we will get -1. All right, -1. So here it says index of can be incredibly useful for quickly checking for the presence of an element on an array. We have defined the function quickCheck that takes an array and an element as arguments. Modify the function using index of so that it returns true if the past element exists on an array and false if it does not. So what we can say here is if array index of element is not equal to -1, return true, right? Else return false. Okay, and if we run the tests, that works. But we can make this shorter, because instead of saying if array index of elements is not equal to -1, return true, we can say return, we can just say a return array index of element equals to well, it's not equal to -1, right? Wait, am I doing this correctly? Index of element is not equal to -1. It should return true if the past elements exist in an array. So it's not equal to -1, right? So yeah, so basically this one is like an equality is basically transformed by JavaScript to a boolean. So if this one is true, it is basically returning true. If it's false, it's returning false. So if we're returning that the return of this is not equal to -1, what we're basically saying is that it has found the element, so we're returning true. And if these things are actually equal, it means it hasn't found, so it will return false, right? I hope I explained that well. All right, so let's go forward. Iterate through all an array items using for loops. Sometimes when working with arrays, it's very handy to be able to iterate through each item to find one or more elements that we might need, or to manipulate an array based on which data items meet a certain set of criteria. JavaScript offers several built-in methods that iterate over arrays in slightly different ways to achieve different results, such as every, for each, map. However, the technique for which which is most flexible and offer us the greatest amount of control, is a simple for loop. So here it says consider the following function greater than, and it gets an array, and here greater than 10, and it gets an array, and here we're making a new array, and we're saying for let I equals 0, I less than array length, I plus plus. If array I is higher than 10, greater than 10, new array push array I, return new R. So basically what this is doing is filtering this array, is taking this array and it's filtering only for the elements that are greater than 10, and it returns an array with all the elements greater than 10 from that array. Alright, saying using a for loop, this function iterates through and accesses each element of the array and subjects to a simple test that we have created. In this way, we have easily and programmatically determined which data items are greater than 10 and return a new array containing those items. And they say we have defined a function filtered array which takes R, a nested array, and lm as arguments and returns a new array. Lm represents an element that may or may not be present on one or more of the arrays nested within R. Modify the function using a for loop to return a filtered version of the past array such that any array nested within R containing lm has been removed. So we're basically given an array of nested arrays, so it's going to be an array of nested arrays, and what we want to return is another array where we're basically removing from the array that we're returning all the sub arrays which contain this element, right? So what we want to say is we want to say for let I equals 0, because we're starting from index 0, I less than array length I plus plus, and we want to say if array of I index of, because array of I is actually going to be another array, one of this array, once by one we're going to all of them, right? So we're saying if the current array, which is at array of I, and we say we're calling index of element on it, so we're basically checking to see if element is inside, and we're saying if index of elements equal to -1, which means it doesn't exist in that array. If it doesn't exist, then we want to keep that array. If it exists, we remove it. So we're saying if array I index of elements equals to -1, we want to say new array push array of I, and then we're returning new array, right? What am I missing here? Why is this not working? Run tests. Oh, it is working. Was there? Oh well, it seems all the elements contain 3, but if we put here 4, for example, then that would show this array. But here all the elements were containing the elements, so all of them were filtered out, right? Okay. So here it says create complex multi-dimensional arrays. Awesome, you have just learned a ton about arrays. This has been a fairly high-level overview, and there is plenty more to learn about working with arrays, much of which you will see in later sections. But before moving on to looking at objects, let's take one more look and see how arrays can become a bit more complex than what we have seen in previous challenges. One of the most powerful features when thinking of arrays as data structure is that arrays can contain or even be completely made up of other arrays. We have seen arrays that contain arrays in previous challenge, but fairly simple ones. However, arrays can contain an infinite depth of arrays that can contain other arrays, each with their own arbitrary levels of depth, and so on. In this way, an array can very quickly become very complex data structure known as multidimensional or nested array. Consider the following example. We have an array with a simple array that has deep, then another array which has other arrays inside, and so on. So just with a lot of deepness. Uh, the deep array is nested 2 levels deep. The deeper arrays are 3 levels deep. The deepest arrays are 4 levels, and the deepest is 5. While this example may seem convoluted, this level of complexity is not unheard of or even unusual when dealing with large amounts of data. However, we can still very easily access the deepest levels of an array this complex with bracket notation. So, so here this logs the string deepest, this one, right? So you basically accessing this element, right? You have nested array of 2. No, so this is here, right? So basically it's accessing this array which is at index 2, then it's accessing the second array in here which is this one, which is at index 1. So as you can see, 1, and then it gets 0 and 0 again. I don't know why there is another 0, but I don't know, maybe a mistake. Right, so we can basically go deeper and deeper by keep putting in brackets. We have defined a variable myNestedArray set equal to an array. Modify myNestedArray using any combination of strings, numbers, and booleans for data elements so that it has exactly 5 levels of depth. Remember, the outermost array is level 1. Somewhere on the third level, include the string deep. On the fourth level, include the string deeper. And on the fifth level, include the string deepest. Alright, so it says modify, so that is exactly 5 level of depth. So I'm just gonna modify on only one of these arrays to have 5 levels, and I'm going to put another array here, and in this array at level, so this is level 2, no, this is level 3, so I can put here deep, then I can create in this one another array which contains deeper, and in this one I can contain another array which contains deepest, and I'm not gonna put any other elements because I'm lazy about it. Alright, let's run the tests, and that works. Okay, add key value pairs to JavaScript objects. Okay, so we're moving to objects now. Other most basic objects are just a collection of key value pairs. In other words, they are pieces of data values mapped to unique identifiers called properties or keys. Take a look at an example. We have an object which is like this, and we're basically having player, which has this value, fighting style, which has this value, and human, which is a boolean with this value. The above code defines a Tekken video game character object called Tekken character. It has 3 properties, each of which map to a specific value. If you want to add an additional property such as origin, it can be done by assigning origin to the object. So basically you access the object, and in the object you access the property origin, which might not exist, but if you access it and you give it a value, it will be created on there. Alright. This uses dot notation. If you were to observe the taken character object, it will now include origin property. Haurang also had distinct orange hair. You can add this property with bracket notation. So you can also use bracket notation. For example, when you have something like a sentence, you can't use something like this because there's a space in here. So you're just gonna use bracket notation with quotes, right? So you're saying, okay, this property of hair colors is gonna have the value of dyed orange. It dyed orange. Bracket notation is required if your property has a space in it or if you want to use a variable to name the property. So for example, when they say if you want to use a variable to name the property, they say if you have a variable which contains something like a string, like const property equals hair color, right? And we have an object const human equals, and let's say we have a property inside eyes blue and sex male. All right, and we want to add like the, a property hair color, and this is stored in a variable. We can either do it like this: human of hair color equals black, right? And if we console log human now, that will be on there. Clear. And we get this: eyes blue, sex male, hair color black. Or instead of doing that, if we have this here, if we have this here, what is going on? Copy this here. Here we can say human of property is black, and that will be the same. So we basically can put in brackets, we can put a variable, and that variable will return whatever values in it and put it within the brackets, right? So we get the same thing. And they exemplify this here, right? Const eyes eye color, taken character eyes brown. After adding all these examples, the object will look like this. All right. A food object has been created with 3 entries. Using the syntax of your choice, add 3 more entries to it. Bananas with a value of 13, grapes with a value of 35, and strawberries with a value of 27. So we could just go and add them in here if we wanted, but we want to add them programmatically to an object. So what we want to say is, well, it also say only change code below this line. So we want to say foods of bananas equals 13, and let's use the other one, foods, and we can say of grapes equals 35, and foods strawberries equals 27. All right, run the tests, and that's it. Alright, here it says modify an object nested within an object. Now let's take a look at a slightly more complex objects. Objects' properties can be nested to an arbitrary depth, same as arrays, and their values can be any type of data supported by JavaScript, including arrays and even other objects. Consider the following: you have this, and then you have a property which has another object which has some properties, and another property which has some other object, and so on. A nested object has 3 property. So it says it has three properties: ID, value is a number, date value is a string, and data value is an object with its nested structure. While structure can quickly become complex, we can still use the same notations to access the information we need. To assign the value 10 to the busy property of the nested online status object, we use dot notation to reference the property. So basically you're saying nested object data, so now you're in here, and then you're accessing online status, so you're in this object now, and then you're accessing busy, and you give it the value of 10. So here it says, here we've defined an object user activity which includes another object nested within it. Set the value of the online key to 45. So what we want to say, we want to say user activity, we want to go in the data object, so we go in data and then in online and give it a value of 45. All right, let's run the tests, and that's it. All right, well, this has been one lonely live because I only see one person live, but nobody's talking. But we're learning. I haven't really learned anything new until now because I know most of the stuff as I've been working with JavaScript for over a year now. But hopefully if somebody is watching this in the future, they can learn something, and hopefully I explain well some of the stuff. In the first object challenge, we mentioned the use of bracket notation as a way to access property values using the evaluation of a variable. For instance, imagine that our food object is being used in a program for a supermarket cash register. We have some functions that set the selected food, and we want to check our food object for the presence of that food. This must look like this. Let selected food equals to get current food of scan items, right? So this function will basically be called, and it will return a string which will basically give you the name of the selected food, and then you basically uh, use that selected food that you get back from that function to check the foods object to see if that food is in there. This code will evaluate the value stored in the selected food variable and return the value of that key in the foods object, or undefined if it is not present. So if the food is not in the foods object, it will return undefined. If it is there, it will return its value. Bracket notation is very useful because sometimes object properties are not known before runtime, or we need to access them in a more dynamic way. So here they say we've defined the function check inventory, which received a scan item as an argument. Return the current value of the scanned item key in the foods object. You can assume that only valid keys will be provided as an argument to check inventory. So what we want to say is return foods of scanned items. Foods, and we get 25, right? Because this is apples and we get 25, right? Let's run the tests. All right, so this is where we're stopping today on this one. We will continue from this place. Probably on Saturday I'm making the next live. If you are here watching, I hope you will learn something from this one, and if you didn't already give a like, please give a like, as it will help YouTube recommend this content to more people. Alright, I hope you have a good evening, and I'll see you next time. Bye bye for now.